Okay, so good morning, all. Just we can do the recap of yesterday's session. Okay, then we can jump into the practicals. Okay, so let me share my screen. Okay, so are you able to see my screen?
Yeah.
Okay, so yesterday we discussed about this diagram, right? Okay, so okay, where is yes, this is the one. Okay, so here is the like the master directory of the PostgreSQL, or we can call it as a data directory of the PostgreSQL. Under the master directory, we have the base subdirectory. Under the base subdirectory, we have the like database OID. Under the database OID, we have the table files. Okay, so suppose if we create any table or index, okay, the table or index, then table file will be created or index file will be created, okay, with the unique number. Okay, those unique numbers we can call it as the OIDs. Okay, we can call it as OIDs, object identifiers. These OIDs are internally managed by PostgreSQL. Okay, so so we have the two types of table spaces in PostgreSQL by default, and third one is the customized table spaces that like as a DBA we need to create customized table space and point out to your preferred location. Okay, so by default, like whenever if you create like PostgreSQL cluster, you get in the PG underscore default table space. So if you create any database without specifying any table space name, so then, so under the base, master base directory, there is a subdirectory. Under the subdirectory, we have those kind of databases where this will be created. Okay, there will be no names here under the base directory, so we can have the only numbers. Okay, so those numbers names we can call it as OIDs. Okay, and which database belongs to which OID we can get it and we can retrieve with help of the catalog views. Okay, so if you want to pick or if you want to find like OID of the database, we have the like catalog view, that is PG underscore database. Okay, there we have the number of options to pick information about the database. So one of the option is OID. Similarly, in the related to table, we have the PG underscore class. Okay, the PG underscore class is equivalent to DB underscore tables or all underscore tables in Oracle. Okay, and PG underscore database is like V dollar database. Okay, so that is the like equivalent view in Oracle. Okay, so like that way, like we can get it the OIDs of the relevant databases, but we can see like which database name. Okay, suppose my database name is the DB one. Okay, so we want to find, you can see if you go down into the like base subdirectory, you can see number of OIDs. Okay, the name means it means a lot of numbers. Okay, but so numbers means we don't know, right, which number belongs to which database, or which number belongs to which table or index. Okay, so to pick that information, we have the relevant catalog views. With the help of those catalog views, we can get the information. Okay, so this is the path. So if we just simplify the path like for the PG default location. Okay, so whenever if we create any database or any table, okay, so how the table will be created? Okay, table will be created under the base subdirectory. Okay, and then followed by database OID. Okay, and then followed by table OID or index OID. Okay, so this we already discussed. Okay, and also one more important thing is, okay, this table, whenever if we create any table, the table will be created with 8 KB of the size. That is a page, like the page size. Okay, in PostgreSQL default page size or OS block size is, or DB block size is 8 KB. Okay, so initially the table file or like data file or real file node. Okay, it will be created. Okay, it will be created with 8 KB size. Okay, and it will grow until 1 GB. Okay, it will grow until 1 GB. So it means like it will like based on your insert operation or based on your update operation, it is automatically pick or like that particular pages will be allocated by PostgreSQL engine automatically to that particular table file. Okay, and it will grow until 1 GB. But this is the 1 GB is the default size. But in our like PostgreSQL cluster, you don't want to have the 1 GB of like file size. Okay, the table file size. Okay, so while initializing the cluster only, you can change this particular value instead of 1 GB. Okay, you can pick whatever size you want. Okay, but the recommended size in PostgreSQL for the community or the like enterprise, okay, that is the 1 GB. Okay, guys. Okay, so up to here, I think it is clear. Okay, and then we can jump into the customized table spaces. Okay, customized table spaces. Okay, so whenever if you create customized table spaces by specifying the location, okay, by specifying the location, by specifying the custom location, the entry, okay, the entry of the table space OID, okay, the entry of the table space OID will be created under the PG underscore table space subdirectory. Okay, so here we have the like default related all the OIDs will be sit under the base subdirectory. Suppose if you're creating any customized table space, so then customized table space related OID will be created under the PG underscore table space subdirectory. Okay, here there is no OID relevant to the table space. Why? Because by default it is storing under the PG underscore default. Okay, even the PG underscore default, maybe in your mind you have a doubt. Okay, so is not like PG underscore default is not having the OID. Yes, PG underscore default table space also having the OID, but internally it is not like it is managing the OIDs. But if you are using that particular PG underscore default table space, okay, the OID names will not be appear here under the base directory, but logically it is managing. Okay, but if you're like creating your customized table spaces, okay, the OID of the table space will be created under another PG underscore table space subdirectory, and it is having the symbolic link. Okay, it is having the symbolic link and pointing to the actual location where you are going to store your data. It means the customized location. Okay, so the customized location, like suppose you pick this is the location of you want to store your all your table files. Okay, so then in the particular location, okay, there is a folder will be created automatically by PostgreSQL. Okay, the folder name will be unique. Okay, the folder name will be unique. Okay, the folder is containing total 3 values. Okay, or maybe 3 components. Okay, one is a like common one, that is a PG. Okay, and PG underscore, then followed by the major version of your PostgreSQL cluster. Okay, the major version of your PostgreSQL cluster, and followed by the catalog version. Okay, and followed by the catalog version. Okay, so then after suppose if you are using maybe the default table space for your particular database. Okay, the default table space for particular table space is a customized table space. Okay, then what it will happen, the OID of the database will be created under this particular location. Okay, under the customized table space, this folder location. Okay, so whenever if you create any table under the particular database, okay, by referring the customized table space, okay, so the flow will be same. Okay, so whenever if you create any tables or indexes under any database, okay, under the particular database, your table or like your relation related OID will be generated here. Okay, so up to here clear, guys? Any doubts? You guys, today Friday. I
Now,
think you're not sleeping, right?
clear, yeah.
Okay. Okay, Banu, Abhishek, and who else? Darpan.
Yeah, it's clear.
Okay. And who else in here? Let's see, drag it. Okay, Southern, it is clear for you, right? Okay, silence means clear. Yeah. Okay, so then we can just go to the slides, which is the one. Okay. Okay, so yeah, this is the same picture we covered. We don't want to repeat the same. Okay, so like just to recap related to Cloud SQL, Postgres SQL. Okay, the Cloud SQL, Postgres SQL, as we said in our yesterday class. Okay, so here in almost every cloud. Okay, so only Google is coming with the Omni flavor of the like LIDB. Okay, only that one is having a like. The OS location, it means like PostgreSQL, Enterprise PostgreSQL flavor from Google is available on on-prem systems, and Enterprise DB is like one of the like on-prem PostgreSQL provider. Okay, so apart from this, if you think about any cloud SQL databases, means the PostgreSQL on top of the cloud. Okay, Amazon or like Google or Azure or Oracle Cloud Interface or any blah blah like any the cloud vendors. Okay, so the PostgreSQL is coming as a database as service. Okay, it is managed by like the infra is managed by the cloud vendors. Okay, so we don't have as a DBA, we don't have any access for any physical location. So in that case, the PostgreSQL table space management so in case of any database as a service of the PostgreSQL, we have only two like table spaces. Okay, and one is a PG underscore data default, and second one is a PG underscore global. Okay, we don't have any option to create the customized table spaces. Okay, so if you're playing with cloud databases, so then all your user data is going to store under the PG underscore default. Okay, so there is no concept of the customized table spaces in any cloud databases. Okay, since that is a database as a service, there is no infra access for any database administrators. Okay, guys. Okay, we can cover next slide. Let me put slide more. Why? Because this content is very small. System is too slow. Guys, you are able to see my screen?
Can see your screen.
Okay, so just the same what we are discussing here, we are going to practice in the lab as well. Okay, so the first thing, suppose if we create like sample DB. Okay, the sample DB is my database name. Okay, and the OID, suppose the OID is like 16384. Okay, so how it will be created in OS location. Okay, if you go to the PG data, this is my master base directory. Under the master base directory, we have the base subdirectory. Okay, we have the base subdirectory. Under the base subdirectory, we can have this OID of the database sample DB OID of our database will be created. Okay, this is the location. Okay, here we are not using any customized table spaces, so that's why. Okay, that's why the OID of the particular database will be created under the base subdirectory. Okay, suppose you connected to this particular sample DB database. Okay, and you created the sample table. Okay, in this situation, okay, so we can pick okay, one of the way of finding the OIDs of the table is by using the PG underscore class. Okay, the PG underscore class. Okay, there you can find the relation name. Okay, guys, you remember, right? Okay, relation is nothing but table or index in PostgreSQL. Okay, then OID. Okay, then OID, then real file node. Okay, the real file node is equivalent to table file or data file in PostgreSQL. Okay, so here you can see the relation is the sample table. Okay, the OID of the sample table is 18740. Okay, and the real file node. Okay, the real file node name is 18740. Okay, this OID of the sample table will be unique always. Okay, guys, I'm telling here. Okay, so whenever if you create your table or relation, okay, the relation might be in table or index. Okay, the relation OID will be unique until you drop your relation from the database cluster. Okay, but the real file node, okay, the real file node, okay, initially whenever you create your relation in your PostgreSQL cluster, okay, in the initial stage, the OID of the relation, okay, and OID of the real file node, okay, both are same. Okay, guys, any confusion here? Okay, what I'm trying to say is, okay, whenever if we create our table or whenever if we create any relation table or index in PostgreSQL cluster, okay, so the OID of, okay, the OID of your particular table or relation, okay, and the OID of the real file node, okay, the both are same, okay, the both are having the same numbers, okay, okay, so those locations will be created in the OS directory this way, okay, anyhow, we will show you, okay, we will show you after the slides, okay, so this is our base subdirectory, okay, this is the OID of my sample database, okay, and this is OID of our sample table, okay. Initially, okay, the OID of the sample table file or real file node will be the equivalent to OID of the sample table. Okay, so we will cover this point, then you will get like better understanding. Okay, so here up to here is clear, right, guys? Okay, it will be clear. Sorry.
It's clear, Siraj.
Okay, okay, okay. Then you can see here. Okay, so what I told you. So initial stage of the sample table creation. Okay, so the OID of the sample table and real file node or table file will be the same number. Okay, and the OID will be unique for, okay, until you drop or until you delete this particular table, okay, or the relation or index from the database cluster, okay, the OID of the relation will be unique, but the OID of the table file relevant to this particular table, okay, it will be changed, okay, it will be changed. When it will be changed, okay, whenever if you are performing any truncate operation, whenever if you're performing any reindex operation, whenever if you're performing any clustering operation, okay, the OID of the table file will be changed, okay. So as a DBA, we are not changing anything, okay. So the PostgreSQL will change this particular OID of your table file or data file or real file node internally, okay. So after you do these kind of operations, okay, even in the lab we can discuss, okay, how if perform truncate operations, okay, how it will be changed, okay, we will see these things, okay, but I think it is clear for you, okay. The OID of your relation will be unique, okay, through and to lifespan of the particular table or index, okay, but the table file or data file or real file node, okay, that will be changed, okay, and maybe you have a doubt, how the relation between this particular OID and this particular next number of suppose if you keep on doing the truncate operation, it is the keep on this real file node or table file number will be changed, okay, not a problem as a DBA from your side, okay, the PostgreSQL internally will manage these OIDs numbers, okay. There will always be a relation between the OID, okay, and the relation is it is internally it is having the track, okay, what is this OID belongs to which table, everything will managed by PostgreSQL internally, okay. So up to here clear, guys? We will show you how these OIDs will be change.
Yeah, one
Okay.
question. Please go ahead.
Yeah, please. Someone is asking.
Yeah,
Dar-
two people asking. Please go ahead. Someone else was also asking.
Mhm.
Yeah, Raj Gopi here. The OID of the table will be always unique, you said, right? In
Mhm.
case if you are drop the OID of the table,
Mhm.
the same number will be assigned to some other table. If
No,
in
no,
case
no. No. See, that is the beauty of PostgreSQL. Okay, if you drop the OID, the same number will not be appear in the PostgreSQL cluster again. Okay, so even which OID number will be allocated. Suppose I created my table at 6:55 AM IST. Okay, in the next microsecond only, I created another table T2. Okay, so suppose initially my table OID is like 1. Okay, we should not like maybe we should not think in microsecond only I create a T2 table. You will not get the next number is not 2. Okay, it is automatically or it is randomly allocated by PostgreSQL engine.
Okay.
Okay, so the like direct answer to your question, yes, there will be same OID will not be utilized in future. It may be anything. Even
Okay.
as a DBA, even we don't have any control on these OIDs. Okay, yeah, I think Darpan, please ask.
Yeah. So what has been mentioned here is the OID wouldn't change. That is unique across the life of the object. Rel file node. What I mean, why do we see it here? I mean, what is the significance? And also, why does it change on a truncate operation? What I mean.
See, what it is happening whenever if you perform the truncate operation or reindex operation, okay, so internally PostgreSQL doing the reconfiguration of the files, okay, internally, okay, it means it is going to recreate the file, okay. So maybe we can say the reindex operation in PostgreSQL or maybe defragmentation time, what it will happen in Oracle. Suppose if you're performing the defragmentation by using any online method or maybe like your own method, okay. So what it will happen in Oracle?
A copy will be created, right? That's what.
Yes, it will be recreated in your like disk location. That's why if you're performing any defragmentation activity in your Oracle system. So suppose I have a like 1 TB of table I'm planning to do the defragmentation. Okay, so then we need to have like 2 TB of the space. That is a recommendation. Okay, what it will happen internally, it will recreate your table. Okay, and it will do the defragmentation. Okay, in the similar way here also internally it will do kind of defragmentation kind of thing.
All right, understood. So what is the significance in the sense as a DBA, where would we need this information? Rel file node. Do we need to look up this information for some other purpose during some activity? And that is why we are looking at it?
No, actually, to be honest, like to better understanding of the like internals, okay, so we are discussing about this OIDs concept, okay. To be honest, as a real-time systems, okay, so like very rarely we will see the OIDs of the tables, okay, and also we like maybe in this way, okay, we can less bother about these OIDs in the real-time systems, okay. So why? Because as a DBA, we don't have any control on this. Okay, then what is the use of choosing or maybe seeing every time these OIDs? Okay, so these OIDs maybe in real-time systems we can say, suppose if there is a like activity or maybe there is a data movement. Okay, so there is a data movement activities like planning. Okay, so we need to pick this OIDs, the set of the OIDs, how many OIDs we have in the table. Okay, so my space is like almost filled. Okay, I want to move only one table from one table space to another table space. Okay, in this situation, so we need to play with these OIDs. Otherwise, as a DBA, okay, even we don't want to bother about these OIDs since we don't have any control in our hands to do the control of these OIDs.
All right, got it for now.
Yeah, and just want to add to Raj. So even like whenever we are doing any table space, if you want to relocate table space from one file system to other or from one location to other, so at that moment you could see if you create any customized table space, you have a soft link between PG table space to your customized, right? So if you migrate that table space to other directory, you have to take the OID, and if you migrate, you have to create the soft link again with manually. Okay, so at that moment only it will be useful. At that moment, we have to pick the OID and we have to point out to the new location where we have to migrate. Yeah. So apart from this, as Raj said, like we don't bother about this OIDs.
Yeah. And Darpan, I think this is for you. Okay. So the homework for you is, okay, so after completion of this class, okay, we are not going to share, okay, for everyone, not only Darpan, just like kidding, okay. So not only for Darpan, for everyone, okay. So we will complete, maybe in half an hour, we will complete about even the lab also. Okay. But the homework for all of you guys is, okay, so we will create one table space. Okay. We will create one customized table space. Okay. And the thing is, we need to move this customized table space into another location. Okay. How we can move? What are the steps involved into that? Okay. What are the steps involved into that? How we can bring up your PostgreSQL cluster after moving into your table space. Okay. This is the homework for you guys. Okay. And especially for Darpan.
Yeah, I've done this. What you have to do is you have to link it, right? ln-s and then link it
Yeah.
that I've done.
That then perfect. Okay. So for like remaining people, okay, I think Darpan is in like very advanced now. Okay. So for remaining people, guys, okay, just like do the practice. Okay. Just we will guide you. Okay. So if you have any issues. Okay. Why? Because those kind of activities in real-time systems we may do. Okay. So like maybe if you have any space related constraints, okay, in the situations you will plan for all those things. Okay. So that is better understanding. If we will provide the document. If you want, even we will show you also. Okay. Okay. But practice from your side. Okay. Practice from your side. If you have any issues, like please let us know. Okay, guys. Up to here clear, right? Okay. So whenever if you perform any truncate, reindex and clustering operations, so we will get the different real file node. Okay. And another way of finding the like OID of your entire path of your particular table or relation or index, anything. Okay. So we have a like function called pg_relation_file path. With help of this particular function, we can get the like the complete OS location of your relation. Okay. So this one we already discussed. So initially the table or index file will be created with 1 GB. Okay. So whenever that 1 GB file is filled, okay, okay, so then next file will be automatically created, okay, by appending the like 1, 2, 3 numbers. Okay, it is something like that. Initially, suppose my OID of my table file is 19427, okay, 19427, okay, then what it will happen? So it is going to fill, then next file will be automatically allocated by PostgreSQL engine. Okay. Then the number is like same real file node .1. Okay. Even this one is also filled, then .2 and so on. Okay. So clear, guys, this slide? Okay. Okay. So here we need to discuss about the two important terminologies or maybe two important technology related like PostgreSQL. Okay. So during the architecture related to page layout, okay, or maybe history of our pages, okay, or maybe like page internals, not history, page internals time. So we discussed about the FSM. Okay, we discussed about the FSM. Okay, so FSM and VM. Okay, these two are like components playing the very crucial role in PostgreSQL. Okay, and FSM actually what it will hold. Okay, FSM having the free space information about your page. Okay, how much of the free space is available in the page. Okay, and every time this FSM information will be updated in PostgreSQL page headers. Okay, so based on this FSM, okay, only, okay, the PostgreSQL engine will pick which page I need to pick for my writing or my updating the data. Okay, so into the particular page. Okay, in maybe in direct word. Okay, in this way. Okay, FSM is a like the space calculation related component in PostgreSQL pages. Okay, it is holding the information about the page, how much of the free space available in your particular page to store your insert or update operations. Okay, and the next thing is FSM for each table and each index. Okay, the FSM will be allocated into your table file. Okay, So, and next one is visibility map, VM, visibility map. Okay. This one is a very, very important concept in PostgreSQL. It is relevant to vacuuming operation. Okay. If you're thinking about the vacuuming operation, that is highly, okay, maintenance task in PostgreSQL. Okay. Whenever if you're performing the vacuuming operation, okay, so the improvement, okay, the performance of the vacuuming operation is going to improve by visibility map. Okay, it is not not there from the like initial version of the PostgreSQL. Okay, it came into the PostgreSQL. Okay, I think it is from 9.2 somewhere, or maybe yeah, 9 version, from 9 version. Before that there is a like very huge amount of issues in the vacuuming operation. Okay, but once the visibility map is like coming or introduced by the PostgreSQL community, okay, then there is a like very good improvement in the vacuuming operation that we will discuss in vacuuming classes. Okay, but for now visibility map is holding the information about the dead tuples. Okay, it is holding the information about the dead tuples. Guys, here dead tuples are nothing but okay, whenever if you are performing the huge amount of the DML operations, okay, the DML operations, it may be delete or it may be update, okay, it may be anything. Okay, so the deleted records are the pre-image records. Okay, those records will be stored within the same table file or within the same table. Okay, guys, okay, in Oracle, if you think about the Oracle, okay, where exactly the pre-image data will store as a DBA, you know, okay, we have the undo table space management in Oracle. Okay, all your pre-image information will be stored into the particular undo table space based on some retention. Okay, but here in PostgreSQL, there is no undo table space management. Okay, the pre-image data will be stored within the same table. Okay, within the same table. Okay, along with the live tuples. Okay, so dead tuples will be stored. Okay, the dead tuples will be stored in the same table, and also live tuples will be stored in the same table file. Okay, but how we can play with these dead tuples and live tuples? Okay, up to what time, when exactly that the tuple will become the dead? Okay, so how it will be reused and how it will be reutilized? Okay, everything we will discuss in the vacuuming, and also we will discuss before starting this vacuuming operation. We are going to cover the MVCC technique. Okay, there you will get the better understanding. Okay, but for now, so visibility map is a one important component in PostgreSQL. It is having the information about the information about the dead tuples in the pages. Okay, in the pages during the vacuuming operation. In PostgreSQL, visibility map is helping to do the vacuuming operation by skipping the pages which are not having the dead tuples. Okay, so visibility map is like, while doing the vacuuming operation, it is simply skipping the pages which are not having the dead tuples. Okay, so with help of this vacuuming operation will not go for the entire table related page full scan. Okay, so it will scan only the pages which are having the dead tuples, and it is going to perform the vacuuming operation. It means directly or indirectly. So if the table is having the index, and if your table is having without index, okay, so you know right, as a DBA you are working from many years. Okay, so with index and without index, how like the scan will be happen on the table. In the same way, visibility map, okay, visibility map is, maybe we can call, or maybe like just for your like understanding, visibility map we can call it as a index on top of the page. Okay, so it means it is containing the information about the dead tuples. Whenever if you performing any vacuuming operation, okay, it is simply skip your like live tuples related pages. Okay, so suppose I have like maybe 1 crore related records in my particular table. Okay, so or maybe 1 crore related pages in my particular the like table file. Okay, so in the 1 crore, suppose 30 lakhs pages having the dead tuples. Okay, and 70 lakhs having only live tuples. Okay, so suppose if I'm doing the vacuuming operation on the same particular the table, okay, a table file, okay, what it will happen before 9 versions, okay, it will go for entire 1 crore related page scans. Okay, instead of 30,000, which are having the dead table pages, okay, it is going for total like 1 crore related pages. Okay, so you got it right. So scanning only like 30 lakhs related like pages scans. Okay, it is in generally it is like fast. Okay, instead of like scanning 1 crore pages, 30 lakhs only you are scanning, and 70 lakhs related pages you are like skipping. Okay, so with help of this vacuuming operation is very fast. Okay, from the from after like 9 point any later versions. Okay, so once it is introduced, it is improving the vacuuming operation. Okay, and and we can discuss about like this particular diagram. Okay, whenever if we create any table file, okay, okay, immediately the FSM VM will not be generated. Okay, FSM VM will not be generated. If we start loading the data inside that, okay, if we start loading that data inside the table, okay, and if we start like doing the DML operations, okay, the FSM and VM like extensions will be created. Okay, these two things holding the information about your table file. Okay, and the table file means the table is nothing but combination of the pages. Okay, it is holding, the FSM is holding the like how much of the free space is available in our particular table file related pages. Okay, and VM is holding the information about what are the like pages having the dead tuples. Okay, any doubts, guys? Guys, I think you are here only.
So the visibility map only will be stored in the indexes only, right? It will not be stored in the tables. Only for the FSM, it will be stored in the tables and indexes.
Exactly. Yeah. Thanks for reminding. Yes, Gopi. I missed that point. Yeah. Yeah. Visibility map is only for the table. Okay. Visibility map is only for the table. Okay. FSM we can create for like both table and indexes. Okay, so during the vacuuming operation, okay, why only for the like the table, VM is only for the table. Okay, during the vacuuming operation you will get the better understanding. Okay, if you go into that topic again, it will be very it will take time. Okay, so there you will get better understanding, but for now you can understand. Okay, FSM and VM. Okay, so the table having the like both FSM and VM, but only index is having FSM. Okay. Any doubts, guys?
One question.
Yeah.
So regarding that real file load,
Abhi.
so it will created automatically. Means that FSM and that VM, so it will create automatically whenever we are creating any tables
Yes.
in that OID.
Yes,
And
exactly.
My question is, who will decide? Because whenever we are truncating or deleting any table operations, that OID will be changed. And who will decide that in the complete system?
Actually, that is the beauty of the PostgreSQL. As we said in like the previous slides also.
Yeah.
Related to OIDs, okay, related to OIDs, even if you have like master DB of the PostgreSQL, you have like full rights of the PostgreSQL, you have the master passwords also in your hand, okay, we don't have any control. These OIDs is managed by PostgreSQL engine internally. Okay, so as a DBA, we don't have any control. It is automatically managed by the PostgreSQL engine.
Okay.
Okay. Yeah. Okay, these are some like we can say like the core differences between the Oracle and PostgreSQL. Okay, so actually in Oracle you can see we have the like these are the some default table spaces we have. Okay, we have the system table space, which is having the data dictionary information. We have the undo table space for like pre-image data. and we have the users table space for user data, and also we have the sysux table space, some performance related tables data. Okay, but here in PostgreSQL, okay, we have only two table spaces, okay, and the system table space is equivalent to PG underscore global table spaces in PostgreSQL, okay, and we don't have any undo table space separately in PostgreSQL, okay, and but undo table space information, okay, the pre-image data information will be stored into the same table file, okay. Maybe I don't want to take you into that direction, okay. So why? Because how the pre-image data will come, okay, and how much time it will be visible, okay, and all those things you will get in MVCC, multi-version concurrency control, okay. There we will discuss more about this undo related, pre-image data related information, okay, how it will manage the data consistency and everything we will discuss there, okay. But for now, just there is no undo a table space management in PostgreSQL, okay. In the same table file, the undo segments will be stored, okay, and the user's table space in Oracle is equivalent to PG underscore default table space in PostgreSQL, and there is no sysux table space in PostgreSQL. Okay, guys, up to here clear?
And one more question here. Can you go to the previous slide? So
Yes.
here what we are saying in the page default table spaces, right? If you are creating any table, by default it will be mapped to this table space unless we are creating the custom table space, right?
Yes.
So if in case if you are having custom table space as a default table space, is there any way we can assign to, instead of custom table space, those data needs to be assigned to the default table space means? Is there any way?
Yes, we can do that.
Okay.
Yeah, that we can do that. Okay. So 717, okay. So we have, yeah, maybe we can try to cover as much as possible in practicals. Guys, you are able to see my screen?
Yes.
Okay, so, oh, sorry, see if you are a Oracle DBA from many years, this is a like Pimon will come. Okay, space. Okay, so I install, like, I'm not like created any directories here. Okay, just like I'm using default a data directory location. Okay, and default my bin directory location. Okay, so what we can do, okay, just we can connect to the PostgreSQL. Okay, so and what we can do, okay, so first we can see what are the databases we have. Okay, so we can play with, okay, first we can create one database, and before that what we can do, -d pg underscore database. Spelling mistake. Okay, this is the catalog view. Okay, this is the catalog view. Okay, with help of this particular view, we have the options here to find what exactly you want. Okay, so here what we can pick select OID. Okay, that name is database name. Then what else? Okay, so this one, if I add now, it will be like it will create doubt for you. Otherwise, maybe we can add now only. Okay, not a problem. Okay, this is a table space related to your database. Okay, I think that's enough. Okay, from PG underscore database. Okay, here you can see Postgres templates 1 and template 0. These are the default databases, and test is our like customized database. Okay, and you can see the OIDs. Okay, you can see the OIDs here. Okay, you can see the OIDs here, and here the OIDs of the table spaces. Okay, the OID of the table spaces. Okay, what we can do, we can even pick PG underscore table spaces. Table space only. Okay, select OID space name. Okay, from PG underscore table space. Okay, you can see here. Okay, Postgres template 1 and template 0. Okay, it is having 1663 is the OID of the default table space. Okay, and these are the OID of the like default databases. Okay. Now what we can do, so with help of the PG underscore database and with help of the PG underscore table spaces, okay, we can find the OID of your relevant objects. Okay. And then now what we can do, we can create database. Okay. So the database name is suppose SkyDB. Okay. So I'm not like changing anything, guys. Okay. I'm not changing anything here. Okay. I'm not mentioning any table space name. Just I created my a database. Okay. That then we can find the like OID of the particular SkyOps DB. Okay. So OID of the SkyDB is, okay, 24620. Okay. 24620. Okay. So and what we can do, we can connect here. Okay, we can connect to SkyDB. Okay, so we connected to SkyDB now. We can create one sample table. Create table T1, suppose ID ENT. Okay, so now I want to find what is the OID of my T1 table. Okay, so we have the like view called /d, okay, PG underscore class. Okay, so here what you can pick, select OID and the relation name, and what we can pick, okay, and this is another important one. Okay, a real file node. Okay, so from PG underscore class, where we can pick relation name equal to T1. Okay, so or maybe this way we can. First we can pick, for your better understanding, OID. Okay, so as we discuss, whenever if we create any table, okay, initially the OID of the relation, okay, the OID of the table, okay, and the OID of the table file, okay, a real file node, a data file, it is same. Okay, guys, it is same. Okay, we can try to, or we can go like physical location. Let me open, I don't know, like where it is. It is inactive. Okay. Let me restart the session. Okay. Okay, PSF and EF grep. Okay. So this is my data directory, or we can go directly PG data. Okay, so where we are now? We are in data directory location. Here we can see, right? Here we can see the base directory. Okay, so in the base directory, okay, so like before checking here, okay, so you got it right, we got it right. So where we are now, we are on the SkyDB. Okay, we are on the SkyDB, and what is the OID of the SkyDB? Okay, so where is here? This one we can pick. Okay, so you can see here. Okay, so we connected to the SkyDB and we created the table T1. Okay, and you know the OID of the SkyDB is 24620. Okay, and where it is storing, it is storing under the PG underscore default. Okay, we like retrieve the information, right? What is the OID of the tables? Okay, these are the like default OID of the PG underscore default table spaces. Okay, and this is the customer tables. Leave about this. Okay, so otherwise we can drop. Okay, let it be. Okay, no, not a problem. Okay, so this is the OID of your database. Okay, this is the OID of your database SkyDB, and under the SkyDB we created the table. Okay, and And as per our discussion, okay, where this should be landed, okay, SkyDB related OIDs. So this is, we are using the customer table space, okay. So in general, as per our discussion, it will be under base directory, base subdirectory, followed by the OID of DB, OID of our DB, okay, and followed by OID of our table. Okay, so it should be like this, right? Okay, it means it will be in our OS location, base directory, base subdirectory. Okay, OID of the table is 24620, and followed by real file node, table OID, a table file OID. Okay, so it is 24621. Okay, so if you understand correct, okay, please confirm. Okay, in OS location, this path will be created. Someone can confirm? Is it true or not?
Yep.
Okay, so we can see the same. Okay, 24620 base directory. Okay, if you see here, 24620 is here. Okay, and these are the OIDs of our like default databases. Okay, we can go here, 24. Okay, and here you can see. Okay, you can see it is containing other real file nodes as well. These are the dictionaries information or some default internal tables related OIDs. Okay, we are going to see our OID, that is, what is our OID? 24621. 24621. Okay, it should be here, right? Where we are.
There's a typo.
2462. There's a typo.
Okay. 62, right? Okay, you can see here where we are now. We are into up to here PG data. Okay, this is the master directory. Okay, and this is a subdirectory here. Okay, this is a subdirectory here. Okay, under the subdirectory, we have the OID of the database. Okay, under the OID, okay, we have the 24621. This is the real file node or table file. Okay, our data file of our T1 table. Okay, or T1 relation. Okay, and Abhi, there is no underscore FSM underscore VM is created, since this is a very like empty file, or maybe we can call it as a like just we created the structure of our table. Okay, whenever if you start loading the data, okay, whenever if you start loading the data, PostgreSQL automatically will create the file something like this. You can see here, suppose for example. Okay, we will show you that one. We will show you. Okay, up to here clear, right, guys?
Yeah, one question. Initially, when a table is created, it would be 8 KB, right?
Yes, exactly.
So the size when you did a LSF and LRT, right, that was 0.
See, that is the empty table. Okay, I will show you just a minute. Okay, so now we will see insert into T1 values. Suppose if I do 1, okay, if no need to comment, this is auto commit. Okay, so now if we type the same command, if you see now,
Understood. Got it. Thank you.
okay, so initially whenever if you create the empty file, the real file node will be created. Okay, if we start loading the data, okay, maybe you may ask me, okay, so like Suresh or Raj, okay, so you are telling FSM and VM will be created. When exactly it will create? Okay, as a DBA, okay, even we don't have any control, automatically PostgreSQL will create. If you start loading the data, okay, if you start loading the data, okay, in a particular point of time, it is automatically will create FSM and VM. Okay, so we don't have any visibility, but if we start loading the data inside that, okay, otherwise what we can do, okay, so okay, you can leave this FSM topic. Okay, why? Because in customized table spaces, we will load the more data and we will delete the more data. There you will get it. Okay, for now it is clear, guys. Okay, it is clear. I can like imagine. Okay, so now what we can do,
Is Suresh there?
So is it audible? I am not able to.
Yeah,
hear it.
I think Sriraj got dropped, I think.
Yeah, maybe.
Yeah, that's what he said in the WhatsApp group. Network issue. Suresh, you there? Or even Suresh got dropped?
Watching bro back.
Yeah, just wait for a couple of minutes. It looks like
Yeah, I'm back, Suresh.
Will be
Yeah, yeah.
joining soon.
Yeah, I'm back. I'm back. Sorry guys, there is a network issue. Okay, so let me restart it. I think I need to do the restart again of my VM. Let me restart my VM. It is completely gone. Just a moment, guys. Just a moment, guys. My VM got restarted. Let me restart. Yes, restart is done. Just a moment. Putty. Let me open my putty session. And what is my IP? This is my IP. Start. 1.1.8. Okay. So open. Guys, sorry for the inconvenience. I think I'm having some issue with the VM. Let me restart. Okay, cancel it. Cancel this. Right. Guys, I think it seems like there is some issue with my VM. I'm unable to make a connection for that. Okay. So don't mind, like, even like Suresh also in outside. So like what we can do, we can continue from here from Monday. Is it fine? Okay for everyone?
That's fine.
I'm getting like
Yeah,
network error.
that's fine.
Yeah, I'm getting network error. Even
But whatever you are covering today, the recording will be saved or it will not be there.
no. Recording will be there. Recording is there. Okay. It is
Okay.
from Suresh system. It's already there. Okay. Issue with my system, not like Suresh system.
Okay.
It will be
Okay.
there. Okay. You'll get it. Okay. If there is no issues from your side, okay, so we can close the class and maybe we can jump into even weekend. Okay, so Monday, it is up from Monday onwards. There are like very interesting sessions. Okay, so the concept is like pages. We are going to take you into like deep dive of the pages. Okay, how internal of the pages. I think someone is asked, right? I think Abhi or someone yesterday. Okay, how the pages? What is the segments here? Okay, what are the extents here? Something like that. Okay,
Yes,
so
yes.
the same thing we are going to discuss from like Monday class. Okay, that is the internal of the page layout. Internals means very internals, in depth of the pages. Okay, and what is the toast? What is the padding? Okay, next week is like also like interesting session followed by the table spaces. Okay, so if there is no doubts from like Abhi, Banu, Darpan, Gopi, Malati, Sadan, okay, we can wrap up the class for today and we can continue from Monday.
All right. Thank you.
Okay, fine.
Thank you.